Check one. Right. Good morning, everybody. Back again to our hydrostatics day 2 session. Already yesterday we did day 1 session. Like initial things were done yesterday. Today is the day 2 session, the continuation of yesterday's session. In case if there are any new people, those who didn't come for yesterday's session is already there in the YouTube. Go to YouTube and you can search, you can watch that. Yesterday, the initial part of hydrostatic. Okay. Hari, before we start, just confirm me whether the video, audio, everything clear from your end?
Yes, sir.
Yes,
All
sir.
clear.
Clear.
Yes, sir.
Yes, sir.
All
Yes, sir.
One moment, I'll check YouTube also. YouTube people, good morning. Hari, ne? Right. Without any further delay, I will start the session. Without any further delay, I'll start the session. Yesterday, we did about initial part in hydrostatics. Under that, we learned about the equation H rho G. Using that, we did questions as well. Today, the second section here, there you go. Transmission of pressure through fluid or liquid. Fluid kya liquid kya transmission of pressure through liquid. Actually, this principle is called as Lamai Pascal principle. Right. What does Pascal principle tells us? What does this transmission of pressure through liquid tells us? Right. Lamai, liquids. Can you compress a liquid? I love you all turn. Can you compress any liquid?
Can't stop.
No, sir.
Very hard,
No,
sir.
sir.
No.
No, sir.
The special thing about liquids is liquids cannot be compressed by applying a force. Now, solids can be compressed. You would have watched that YouTube shorts, Instagram reels, TikTok videos where there's a press there, hydraulic press you call it. Using the press, they keep some object in the middle, they press it and make it chop. I will watch those reels. They make it chop.
Yes, sir.
Most of the time, it is solid that gets chop that get compressed. Chop is compressed. Solid that get compressed. Can a liquid be compressed? No. Can you take the water and can you chopify the water? No, right? It will
No, sir.
splash out. You can't compress liquid by applying a force. Therefore, now listen, therefore, pressure applied at one point in a liquid can be equally transmitted to another point in that same liquid. Again, listen to the words I'm using. As liquids cannot be compressed, pressure applied at one point in a liquid can be equally, listen to the words, equally transmitted to another point in that same liquid. That means, right, let's say you have a piston. Piston can in the injection, you have the syringe part. That's called a piston. Okay. I remove the needle and I'm going to connect a tube here. A tube is connected. Now you need to think very practically and don't think like scientists, think very practically. Here also, I connect a piston. Inside that, I'm going to fill some water. Let's take, you fill water. This fill with water. A simple practical question. Now this is fully closed and no leaks are there, no gaps are there, fully closed and sealed. A simple practical question, very simply think. If I press this, I'm going to press it. I am pressing, I am squeezing. I am squeezing, I am applying a pressure. Yesterday I told you, squeezing is applying a pressure. I am pressing, I am squeezing this. What will happen to this piston?
It will go behind.
I don't practically think at it.
It will move behind.
Will go behind.
Will go back.
Unhurry. When you press this side the piston will come out. Either practically think. You press this side the piston comes out. Why? What's the science behind it? See, inside this you have a liquid. Y'all tell me, can we compress a liquid?
Can't, sir.
Can't.
Can't, sir.
Therefore, when I squeeze this, when I press this, can it get squeezed? No. Even though I'm trying to squeeze this, I can't squeeze it. I can't compress it. As this doesn't get squeezed, what happens? That water will flow. Therefore, the piston comes out. That means when I'm squeezing, I'm applying a pressure here. That pressure has got transmitted into this side. The pressure I apply here, it has got transmitted into the other side. That is what Pascal's principle telling us. That is what transmission of pressure through liquid tells us. What does it tell us? As liquids cannot be compressed, pressure applied at one point in a liquid can be equally transmitted to another point in that same. Now, this is not HROG pressure, right? Am I talking about HROG? Am I talking about depth here? No. This is not HROG pressure. This is an external pressure. I am applying a pressure. This is an external pressure. That external pressure is transmitted. Not HROG. Yesterday's concept was HROG. HROG is this. HROG, point A, you have HROG. I'm not talking about this pressure. I'm talking about a pressure I am applying. An external pressure. That pressure is transmitted. Okay. Hurry, give me a second. I'll plug the charger. Once more, what does Pascal's principle telling us? As liquids cannot be compressed, pressure applied at one point is equally transmitted to another point in that same. Is it HROG pressure? Yes or no?
No.
No.
That is external pressure we apply. Externally, we are going and squeezing it. External pressure we are. Okay. Tell me some uses of this. Where you can see this happen.
Brake system.
Brake system. In brake system, Pascal's principle is used. Principle of transmission of pressure through liquid is used. Brake system. Have you all seen in service stations, when the vehicle is taken for the service, they lift the vehicle. How they lift the vehicle? Uncle will come and lift it. There's a special
Hydraulic
device.
jack.
Through a piston.
Hydraulic pressure.
Hydraulic jack.
Hydraulic press.
Yes.
Now let's take there is a patch in the vehicle tire. There's a patch in the vehicle tire. Or people keep a red color small part and lift it. A red color, some jack-like thing is kept and lifted.
Yeah, hydraulic jack.
That is hydraulic jack. All of them use Pascal's principle. Hydraulic jack. What are the uses of Pascal's principle? What are the uses? What are the uses of principle of transmission of pressure through liquid? Hydraulic press, brake system, hydraulic jack. These are only given in our book. Otherwise, you can even talk about JCBs. How does a JCB arm work? Have you all seen so many hose pipes are there? Hoses are there, hose pipes are there. JCB arm.
Yes,
That
sir.
also uses what? Pascal's principle. Using Pascal's principle only, it's lifted.
How is the transmission of liquid related to these examples?
How does?
Transmission of liquid related to these examples?
Related to?
These examples?
You're not clear. How does
How
transmission?
does transmission of liquid relate to these examples?
I'll explain those things. I'll explain now. Hydraulic press will be talking deeply, right? So those are some examples of principle of transmission of pressure. I'll talk about hydraulic press. We have so many things to discuss under hydraulic press brake system. I'll separately discuss. So in those things, the principle used is principle of transmission of pressure. That's the principle used. Even I think in your school exhibition, science exhibition, there'll be 1 or 2 fellows who would have made a JCB arm. How they make it? You can make a JCB arm using cardboards and all. How? Using syringe, neda. Huh? Using syringe, you can make JCB arm, right? That's how it actually works. That's how it works. Hari, we'll read a little bit, then I'll explain deeply about it. Transmission of pressure through liquid. The correct name for this is Pascal's principle. Within brackets, write Pascal's principle. But actually, that name is not given in our syllabus. That name is not directly given. Even though we talk about that principle, that name is not given. Just in a pencil, put a bracket and write Pascal principle. Pascal principle. What is JCB arm? JCB arm can yellow color big heavy machine is there which they use to what you call remove soil. Liquids do not get compressed by forces exerted on them. Therefore, the pressure exerted, therefore, we'll use a different color. Therefore, the pressure exerted at one point in a liquid can be transmitted to another point in the liquid. This principle is called the principle of transmission of pressure through liquid. Please underline or highlight it. Hydraulic press. The principle of transmission of pressure, it can be used to lift a heavy object using a smaller force. We'll discuss a little bit deeper about this hydraulic press. We'll discuss a little bit deeper about this hydraulic press. Now listen very carefully. Now I'm going to explain scientifically what is happening in a hydraulic press. Listen, right. What is this hydraulic press? When you go to service station, vehicle is parked there. Maybe if there are any repairs in the under part of the vehicle, they lift the vehicle up. How do they lift the vehicle? Using a hydraulic press. What's the main use of a hydraulic press? You can lift a heavy object by applying a small force. You can lift a heavy object by applying a small force. That's the main use of a hydraulic press. How does it work? How does it work? Right. Hard. This is one arm, smaller one. This is another arm, a bigger one. Understand the mechanism there. Smaller arm is there, bigger arm is there. Right. Here you have a piston. There you have a piston. Here also you have a piston. Listen very carefully. There also you have a piston. A smaller piston in smaller arm, a bigger piston in bigger arm. Right. Inside this, you have a liquid. Usually oil is filled. Usually oil is filled. You have the liquid. Inside it is fully filled with liquid. Right. Now, practically think an answer. Practically think an answer. If I press, I'll name this as A. If I press the piston A, what will happen to piston B?
It will move up.
It will go up.
Go upside.
It will move up.
It will be lifted upwards.
Lifted upwards.
It goes up. Practically think. You press this, press it, liquid gets transmitted here. This part will go up. Practically think, when you press this, liquid get transmitted, it will go up. Why is this piston going up? That is because pressure applied at one point is equally transmitted to what? Another point. What principle? Pascal. You press this,
So, but
liquid moves this side, therefore the piston goes up. Just imagine the force you are applying here is F1. The force you are getting here, if the piston is going up, the force you are getting here is F2. Heavy object is kept here. So F2 should be bigger than F1. Heavy object is kept here. Heavy object, to lift the heavy object, you need to apply a bigger force. So F2 should be greater than F1. F1 is the small force we are applying. F2 is the bigger force we are getting. So F2 is greater than F1. There you go. F2 greater than F1. Next, look very carefully. Look very carefully. Look at the area here. There's a small area, no? Sectional area. A cross-sectional area is there. I take that cross-sectional area as A1. Here you have a bigger area. Here you have a bigger area. I take this cross-sectional area as A2. A1, A2, which one is bigger?
A2.
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 A2. A2.
A2 is bigger than A1. Right.
A1.
Those things clearly we can see in the structure of this hydraulic jet. A1 is small, A2 is big. F1 is the small force we are applying. F2 is the bigger force we are getting, because here only we are keeping the object. F1 small, F2 big. A1 small, A2 big. Those things clearly we can see. Now, what does Pascal principle tells us? What does principle of transmission of pressure through liquid tells us? Liquids cannot be compressed. Therefore, pressure applied at one point in a liquid is
Transmitted
Transmitted.
to another point. Equally transmitted to another point.
Equally transmitted to other
equally
point.
transmitted to another point in that same liquid. Pressure applied at one point in a liquid is equally, that word is important, that is equally transmitted to another point in that liquid. Now see, I am squeezing this need. I am squeezing this piston. Piston A, I am squeezing. I am applying a pressure here. I take that pressure as P. All right. This side, I take the pressure as P1. When I squeeze it, this side goes up. Pressure is getting transmitted. So pressure is coming here. I take the pressure here as P2. I take the pressure here as P1. Here the pressure as P2. Now we'll write equations. Look very carefully. You won't understand this until we do questions. You won't understand. First listen. Right. We have a pressure this side, P1. We have a pressure that side. There you go. P1. We have a pressure on the other side, P2. What can we tell about P1 and P2? What can we tell about P1 and P2?
Both are equal.
They are equal. Why they are equal? That is principle of transmission of pressure through liquid tells us. Pressure applied at one point in a liquid is equally transmitted to another point in that same liquid. If it is equally transmitted to another point in the same liquid, P1 and P2 should be equal. That is what principle telling us. Pressure applied at one point in a liquid is equally transmitted to another point in that same liquid. If it is equally transmitted, P1 is what is transmitted on the other side. If it is transmitted, P1 and P2 should be equal. There you go. P1 and P2 are equal. Now, what is P1? What is P1? Yesterday's work. Tell me, pressure equal. What over what?
Oh, area.
Over.
area.
It's say H rho G. Lamai, when I started itself today, I told you, are we talking about H rho G pressure here?
No.
Rho G concept doesn't come here. We are talking about the general pressure here, the squeeze that we apply. So pressure P is equal to F over A. So you all tell me, what is P1? P1 is equal to what over what?
F1
over
P1 is equal to F1 over A1. P2 is equal to?
F2
over
We'll write that. P1 is F1 over A1. P2 is F2 over A2. These two are what?
equal.
If I rearrange it to make it more nicely, F2 I'll bring it on bottom, A1 I'll take it top or a cross multiplication. F1 over F2 equal A1 over A2. Very important equation in Pascal's principle. F1 over F2 equal A1 over A2. Ratio of the two forces is equal to ratio of the two area. Very important equation when we solve questions. I'm not going to ask whether you understood or not. I know you have confusion. And how it is transmitted, then how small force become big. I know you have big questions. I will answer all those questions when we start doing questions. When we start doing questions only, you will understand how F1 become F2, how A1 become A2, how small force become big force. All those things I can solve it when I start doing questions only. So until then, just put the things to the mind. Don't try to understand this. If you try to understand this, you will go nuts. Don't try to understand this. Just put the things to the mind. Still the section is not over. Hurry. Again, see, what did I do until now? This is hydraulic press. In hydraulic press, you have a smaller arm, you have a bigger arm. You apply a force to the smaller arm and you are lifting a heavy object from the bigger arm. Smaller force you are applying is F1. The bigger force you are getting is F2. Here the area, smaller area A1. Here the area, bigger area A2. You are pressing this cannon, you are applying a pressure here, E1. That pressure is equally transmitted to the other point. That is what Pascal's principle telling us. So P1 is transmitted here. So P1 and P2 are equal. Now we start writing equation. Pressure equal force over area. P1 is equal to F1 over A1. P2 is equal to F2 over A2. Those things I wrote. P1 equal F1 over A1, P2 equal F2 over A2. And by Pascal's principle, we know pressure is equal. P1 and P2 are equal. And F1 over A1 equal to F2 over A2. I again rearrange that. When I rearrange it, F1 over F2 equal A1 over A2. What I can tell? F1 is greater than F2. A1 is greater than A2. නෑනේ අනිත් පැත්තෙන් නේද? අනිත් පැත්තෙන් නේද? F2 is greater than F1. Yes. F2 is greater than F1. A2 is greater than A1. I'm not going to ask whether you understood. Right? So these things should go into your mind before I start solving questions. Without that, we can't solve questions. All right. Finally, one small point. Now, where did my pen go? Now, in a hydraulic press, what do? You lift a heavy object, නේද? In a hydraulic press, you lift a heavy object. ඒ කියන්නේ, what you have here is a heavy object, maybe a vehicle. Question. Answer this one. Answer this question. Answer this question. Let's take weight of the vehicle is 1000 Newton. Weight of the vehicle is 1000 Newton. එහෙනම් you all practically think and tell me, to lift it up, how much of force I need to exert upwards?
Greater than
1000 Newton.
Greater than 1000 newtons.
Minimum force, yeah, minimum force. How much I should exert? 1000. Remember, to lift the object up, you need to exert a force equal to its weight. Water bottle. Let's take the weight of the water bottle is 100 Newton. For me to lift it up, how much of force I need to apply up?
100 Newton. 100 Newton.
100 Newton. If you minimum you need to go 100 Newton. The moment you give 100 Newton, it will go up. But if you give more than 100 Newton, there is an imbalance force upward. Therefore, it can accelerate and go up. No need acceleration. I am talking just when you need to lift it up. You need to lift it up. Downward force 100 now, upward force you need to give 100. If you go now, let's say you give 200 Newton. Upward you have a resultant force. If there's a resultant force, there will be acceleration. F equal ma. There will be acceleration. Then it will accelerate and go up. I'm not talking about acceleration now. In a hydraulic press, we are not going to accelerate and send the vehicle up. No? Right? We are not going to throw the vehicle up. No? We're going to just lift it. So to lift it, you need to apply a force equal to the weight of the object. That point, keep in mind, we need it to solve questions. We need it to solve questions. Hurry. With all those things, we'll write this one. With all those things, I will write this one. I saw most of you had some questions, right? I didn't answer the question because still I'm not done with the explanation. Once I am done with the explanation, then you all ask the questions. At that time, I'll answer. Picture is given. F1 is there, A1 is there, piston A. F2 is there, A2 is there, piston B. මේ line එක නම් ඕනේ නෑ ළමයි. In a hydraulic press, pressure applied in smaller piston is equally transmitted. Please underline or highlight that word, equally transmitted. Equally transmitted. That equally transmitted word is very important.
Can you
equally
show?
transmitted to the larger piston. Therefore, we can derive the following equation. Under that a box is given. In that box, I want you all to write the derivation of the equation. Right there, P1 equal P2. Therefore, F1 over A1 equal F2 over A2. From there, the equation. Yes, write it in that box. This full part. Once done, tell me done. Done. Huh. Now a small question. Now a small question. Listen, when I press this, I apply a small force. From the other side, this goes up. Now, when I leave it, then vehicle should come down. Just practically think. I press it. As long as I press it, this side the vehicle goes up. The moment I release it, vehicle should come down. Isn't it? Just practically think. You press it, you are squeezing. As long as you squeeze it, vehicle is up. The moment you release this side, this should come down. Is it happening in a hydraulic press?
No.
Can it happen in hydraulic press?
No.
No, sir.
Can't.
That happen, vehicle will get damaged. How it is avoided? How it is avoided? Now, when I press it, vehicle goes up. The fluid or the liquid there can move in this direction. Can the liquid go backwards? If it goes backward, what will happen? Vehicle will come down. Can it go backward? Is it good to go backward?
No.
No.
How that backflow of liquid is avoided? How that backflow of liquid is avoided? Listen, in the hydraulic presslamine, somewhere here, you have a valve, a one-way valve. A one-way valve is there. Valve in a tap like. Now see, when I press this side, liquid will come, valve will open. When the valve opens, liquid can go like this. From there, liquid can go. I'll erase the other things are yellow color part. Liquid can go in that direction. But when I leave this side, when I leave that side, now think, when I leave that side, if the liquid tries to flow backwards, what will happen to the valve? Valve will come front.
Close.
When the valve comes front, what is happening?
Lock.
It will close.
It
will
blocks.
close.
So when it
then how
blocks,
do you lower the car?
can the liquid go backwards?
No.
These types of valves are called one-way valve. What valve? One-way valve. One-way valve. It allows the liquid to flow only in one direction. Right? Here, actually, a controlling mechanism is there. When you want to bring the vehicle down, slowly this valve is open. And slowly the liquid go backward. Slowly the vehicle will come down. This is not a mechanical valve. This is a electronic valve. It can open up. It will close. If you want to open the closed valve, you have to slowly press the button, and using electronics, you slowly open it, not at once. Slowly open it, slowly the liquid will flow backwards. When the liquid flow backwards, slowly the vehicle will come down. Okay. So that point is also given. Using a hydraulic press, a larger weight can be lifted using a smaller force. To avoid liquid from flowing in opposite direction, there is a one-way valve in hydraulic press. There is a one-way valve. Picture is given. Okay. Now we will go to the question. Now only all your doubts will get solved. We'll do the question. See, look how I do. A car of weight 10,000 Newton. A car of weight 10,000 Newton. Look very carefully. A car of weight is lifted using a hydraulic press. Area of larger piston is 10 meters square. Larger piston 10 meters square. Area of smaller piston is 2 meters square. Calculate the external force applied. What is F2 here?
10,000.
10,000.
10,000.
F2 is the bigger force. No? Bigger force is 10,000 Newton. What is A2 here?
10
meters square.
10 meters
10
square is the
meters
bigger
square.
area. So A2 is 10 meters square. What is A1 here?
2 meters square.
2 meters square.
2 meters
2
square.
meters square.
Find the F1.
They are asking to calculate external force we apply. External force we apply is the smaller force. Smaller force is what?
F1.
F1 they are asking. F2 given, A2 given, A1 given, F1 they are asking. We'll try to work it out. See how I do. F2 10,000, A2 10, A1 2. Right. Look, now only your doubts get solved. Most of you had doubts here. F2 10,000 Newton, A2 10 meters square, A1 2 meter square, F1 they are asking. What does Pascal principle tells us? P1 is equal to P2. A කියන්නේ F1 over F2 equal A1 over A2. No need to write this one. You can directly start from this equation. I wrote it and showed so that it's clear for you. Right. What is the F1 here? That is what you don't know. I will keep it as F1 divided by. What is the F2 value?
10,000 Newton.
10,000 Newton equals. What is the A1 here?
Meter square.
2 meter square.
2 meters.
2
2
meter square.
meter square. What is A2 here?
10
10
meter
meter
square.
Square.
10 meter square.
They are asking F1. If you need to find F1, you need to subject F1. If you subject F1, denominator should go to the other side. Denominator on the other side become
Multiplication.
multiplication. So that is 2
10,000.
meter square divided by 10 meter square multiplied by 10,000
Newton.
Do the math there. F1 is equal to
2,000.
2 and 10
Newton
will
meters.
cancel off 5. 5 and 10 will cancel off again 2.
2,000
Meter square cancel off. Only Newton is remaining. How much of Newton?
2000.
2000 Newton.
2000 Newton.
2000 Newton.
Now look at the magic here. Now look at the magic here. See. Now look. Now only doubts get solved. See. You are applying only 2000 Newton. But how much you are lifting?
10,000 Newton.
10,000.
So can you see, using a hydraulic press, we can lift a heavy object by applying a smaller force. Equation wise, we can prove that. We are applying a smaller force here, it's converted into a bigger force. The main reason is because two reasons are there. Main reason is because pressure is equally transmitted. Number one. Number two, areas are different. So that relationship only we get this. If the areas are same, we won't get this. If the pressure doesn't get transmitted, if the liquid is compressed, we won't get this. As the liquid cannot be compressed, pressure can be equally transmitted. Pressure is F over A from the ratio of F1 and F2 equal A1 over. Due to that, smaller force can be converted into a bigger force using a hydraulic. The equation wise we can prove. With numbers we can prove. 2000 Newton only you are applying. You are lifting 10,000 Newton. Okay. Now ask your doubt. Now ask the now done. And now only Pascal principle is done. Now ask the doubts.
Excuse me, sir.
One by one.
Can you please explain that one valve thing again?
Which
Valve.
part?
That
Valve.
valve.
Valve section. Sorry. Valve part is puta. See. You have a one-way valve here. Look about the mechanism of the valve. Liquid can go this side. Valve will open. Liquid can go this side. That side the liquid can go. Can it flow backwards? Think very practically. Can it go backwards? If it comes backwards, first it will push the valve. When it pushes the valve, what happens to the valve? Tell me.
It closed.
It closes. The liquid can't flow backwards. That's the valve part. On. All doubts cleared. No doubts. What's the object? 2000 Newton. 2000 Newton is not the object. 2000 is the force applying. You should apply a force. That uncle will apply a force not to lift it. That is the force he is applying. Harin.
Sir,
Yeah.
since Newton's first law, area and
That is something else, no? Some other section, no?
no, by giving force, so since the area is low, we should give a high amount of force to lift the object, right? Like
When the area is small. Again, repeat that.
So could you check the chat box?
Sorry. Chat box. Since the area is small. We need to apply large force. No, there's no such relationship. Area and force, there's no such relationship. There's no such thing that when the area is small, we need to apply large force. That's not area, that's acceleration. Ne? Acceleration and force only has a connection, not area. Hurry. Enalamai, do the first question. Then you all do the second question by your own. First do the first question. In your framework, write down. Principle of transmission of pressure through liquid. Do it, send me the answer for the second one as well. Equation is same, F1 over F2 equal A1 over A2. Then do the math, then find the answer. Do the first one, then go for the second one.
Sir,
Work.
can you share the screen?
Sorry? Yeah, I'll share the screen.
Sir,
First
can
write.
you share the screen?
First write this, I'll share the screen.
So can you please check the chat box?
Do the second question, send me the answer. I'll check the YouTube section. Hurry. Most players send the correct answer. What's the question telling? A lorry of mass, any mass is 5,000 kg. Mass is given. Is lifted using hydraulic press. Cross-sectional area of smaller piston is 5 meters square. Smaller piston. Cross-sectional area of larger piston is 25 meters square. Calculate the amount of force applied. Amount of force applied. applied force only they ask. Right. Question 2. Lorry of mass 5000 kg. Mass of the lorry is 5000 kg. Now, if the mass of the lorry is 5000 kg, first of all, tell me what is the weight of the lorry? Mass is 5000. What's the weight?
50,000.
50,000
Newton.
50,000.
So if the weight is 50,000, if the weight is 50,000, what is the upward force that is applied to lift it?
50,000.
50,000.
Small force or big force? F1, F2.
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 F2 is 50,000 Newton. Cross-sectional area of smaller piston is 5 meters square. A1 is given 5 meters square.
5 meters.
And cross-sectional area of large piston is 25 meters square. Large piston 25 meters square. What are they asking? Calculate the amount of force you are applying. Applied force. Applied force is F1. Now apply the equation.
Sir, F2 is 5,000 Newton.
No, it's 50,000.
50,000.
50,000.
No, 50,000. 5,000 kg. No, 5,000 kg you multiply by 10. 5,000 kg you multiply by 10. That's 50,000 Newton. 50,000, eh? F1 over F2. A1 over A2. From there, F1 you don't know, you need to find it. F2 is 50,000 Newton. Equal. A1 is the smaller area 5 meters square. A2 is the bigger area 25 meters. If you need to find F1, you need to subject F1. If you subject F1, denominator go to the other side. Denominator on the other side become multiplication. That is F1 equal 5 meters square over 25 meters square multiplied by 50,000 Newton. This and this cancel off. 5 will be remaining. 5 and 50 will cancel off. 10. 10,000 Newton.
Yes, sir.
Yes.
Sir.
So what does this tells us? Just by applying 10,000 Newton, you can lift a weight of 50,000 Newton.
50,000 Newton.
Just by if applying 10,000 Newton, you can apply a lift of a weight of 50,000 Newton. Get the advantage of this. Such a big mechanical advantage is there in a hydraulic press. Small force converted into a big force. One of the best invention in the hydraulic section. Applying 10,000, you can lift a weight of 50,000. Such a big advantage. Otherwise, you need to apply 50,000 Newton to lift it. Just by applying 10,000, you can lift 50,000. Very big advantage. Hari, that's about hydraulic press. Those are writing, right and finish it. What are the uses of this principle of transmission of pressure? Principle of transmission of pressure is applied in following instances too. Already we learned about hydraulic press. What else? Hydraulic jack, that is that color thing which you use to lift a vehicle when there's a patch. And brake system. Hydraulic press we discussed, hydraulic jack we don't discuss. Brake system we'll discuss a little bit. Brake system, mechanism of a brake system we'll discuss. Right. There you go. Mechanism of a brake system. How does our brakes work? Mechanism in a brake system. Right. If you take a brake system,
One doubt.
this is called the master cylinder.
The cylinder.
This is like a slave. Master will control the slave. Slave cylinder. Inside it,
Is the brake pads.
you have the brake oil.
Brake fluid.
Oil.
Brake fluid.
Inside that, you have the brake oil. That is what we change every time when we take for the every 30,000 kilometer or something. 30 or 10,000. We change the brake oil. We have to change the brake oil. So brake oil is there inside. That's the brake oil. Now you all tell me. Now you all tell me. When I press the master cylinder. What will happen to the piston in the slave cylinder?
It will be
It will move. Out.
It will come out.
Which
Now, in the slave cylinder, someone is unmute. Right. This is the brake pad. This is brake disc.
is disc brake.
Bro, nicely. That is the tire. The wheel there.
Yeah.
Tire, the wheel there. Wheel is connected. When the wheel is rotating, when the wheel is rotating, brakes will also freely rotate. Near the brake disc, you have the brake pad. Brake pad is connected into the slave cylinder. Slave cylinder is connected to the master cylinder. Now mechanically think. Right. When I press the master cylinder, fluid goes to the other side. What will happen to the piston in the slave cylinder? It comes
Out.
when the piston in the slave cylinder comes out,
Outside.
Lamai, what will happen to the brake pad? It comes closer or goes away.
Closer.
Closer.
When the slave cylinder comes front, brake pad will come closer.
Yes.
It's not moving. This pad is stationary. This pad is moving. So this pad will come closer. When that pad comes closer, it will go and hold the disc there. Practically think disc is there in the middle. When the brake pad comes closer, can you see? Yes. When the brake pad comes closer, it holds the disc. When it holds the disc, can the brake disc rotate?
No.
Can't.
No, sir.
So brake disc rotation stops. Brake disc is directly connected into the wheel. So can the wheel rotate?
No.
That is brake. Practical Joe, let's take. This is the brake disc. Brake disc is rotating. What is the brake disc? Near the brake disc, you have the brake pad. What will the brake pad do? Brake pad will come and when it is rotating, brake pad will come and hold it. So can it rotate?
No.
That's the function. This brake pad get backed off after some time, right? That is what people go and change. Brake pad best is during every service time, right? During every service time, you need to go and change the brake pad. Okay. When you see any vehicle, just see near the wheel, there will be a black color dust. There will be a black color dust spreaded in some vehicle wheels. Near the wheel, there will be a black color dust spreaded. What is that dust? That is the worn out pieces of this brake disc. Again, a brake disc is not high quality. If the brake disc is not high quality, what will happen is that brake disc, that powder will get spreaded. Right? In your car, you have no, sir. I have because I drive a lot. Right? I change it during every service. I will, however, change the brake disc. Because brake move in a vehicle more than the accelerator, brake is something that is very much needed. Even you can't drive without a brake. Some fellows will tell, Dani, එහෙම බෑනේ sir, එහෙම නෑ කියලා. එහෙම නෑ ළමයි, without a brake, you can't drive a vehicle. Brake is something more important than any other component in the vehicle. Right? එතකොට brake works. Just imagine while you are driving, suddenly there is a leak here. From here, brake oil is coming out. You all tell me now. If brake oil comes like this, can the brake work? If the brake oil comes like this, can the brake work?
No,
Can't.
it can't.
No, sir.
Cannot.
It won't.
Yes.
An accidental law. Impossible, sir.
The main
Unable.
That's why every week, you have to open the bonnet and see. In the bonnet, you have the brake oil. The brake oil. Even bikes the same. Also, they have the brake oil. You see that you can decrease in the level. That means there is a leak. You need to go and repair it. to check where is the leakage and you
Sir,
need to
your
repair.
voice is tracking.
That's because so many people are talking when I'm talking. So are these cylinders inside the car? Yes, yes, these are inside the car. This system is fully there inside the car. Even in the bike, the same. Bike also you have this type of brake system. Even though I explain it like this, the mechanism is not this. Now, actually, master cylinder is there. A small part is there. Now, how we are going to press the master cylinder? Lamai? How we press the master cylinder? Huh? Do you put the hand and press it? Nah, nah. This master cylinder, yeah. This master cylinder is connected to the brake pedal. That is why you keep the leg and press. So when you press it, this piston goes inside. That's how the brake works. That's how it works. Okay. Even though I draw it like this system is not like this. Master cylinder is there. You don't have one tire, one wheel in a car. No. 4 wheels are there. So this should be transmitted to 4 wheels. Again, there is in the middle, there is again a big mechanism. You press only one. From there, the transmission is given to all the 4 wheels. Right? That's how the process works. Huh. Mechanism of a brake system. Picture is given. Pedal is there. It gets transmitted. This is the brake disc. Master cylinder, slave cylinder. In the brake system of a vehicle, when the driver applies a force on the brake pedal, it is transmitted to the piston. This force exerts a pressure on the oil inside the cylinder. This pressure is then transmitted through the oil to the slave cylinder near the wheel. Then the brake pads are connected to the slave cylinder, are pressed to apply a pressure on the brake disc or the brake drum. Another name for brake disc is brake drum. This cross-sectional area of the slave cylinder is larger than that of the master cylinder. The force applied on the brake pads by the slave cylinder is greater than the force applied by the pedal. Now we apply only a small force, but that force is becoming bigger and it is transmitted into the wheels. That's it. Pascal's principle done. That's it. Pascal's principle done. Voice is lagging. Is my voice lagging, Lamai? Sometimes. Yeah, sometimes you can understand online class. Sometimes you will have. Not really. About the YouTube section. So why your bottle is changed? I mean, bottle is not changed. I have both the bottles. Even to classes I take, some fellows ask, wonder why I have 2 bottles. This bottle I have sustagen. This bottle I have the water. Otherwise, it's really hard to do classes, especially Saturday and Sunday. Full day I have class. I sustagen only do the class. I'm such a kid. Okay. Hurry. Chocolate or vanilla flavor. I like chocolate flavor. Not that I like, but it's so easier. When I'm teaching itself, if I feel little bit hungry, drink a little bit of sustagen. So Hungry. Hurry, right. Back to work. Transmission of pressure through gases. Transmission of pressure. Pressure in gases. Pressure in gases. Now listen. Pressure in gases. Now until now we learned pressure in solids. P equal F. Pressure in liquids. HOG equation. Now coming to pressure in gases. Gases also exert a pressure. Remember, pressure due to two main reasons. Pressure in gases is due to two main reasons. What are the two reasons for the pressure in gas? Number one, there can be pressure in gas due to when compressed gas attempts to expand. When compressed gas attempts to expand, there can be a pressure in the gas. Otherwise, there can be pressure in gas due to weight of the air column. So two reasons for the pressure in gas. One, when compressed gas attempts to expand, there can be a pressure. Number two, due to the weight of the air column or whatever the gas that is. Weight of the gas column. Best example for the weight of the gas column is atmospheric pressure. Atmospheric pressure is due to the weight of the gas column. So two reasons for the pressure in gas. One, when compressed gas attempts to expand. Number two, due to weight of the gas column. Example, atmospheric pressure. Don't go try to understand it. As I already told you won't understand this until I explain about each one of these. Just read these things. I'll explain about these things. Pressure due to gas. Pressure due to gas is because of following two reasons. What are the two reasons? When compressed gas attempts to expand, number one. And number two, due to weight of the column of gas. Example, atmospheric pressure. First, we will go to the first one. Pressure in gas when compressed gas attempts to expand. Pressure in gas. Pressure in gas when compressed gas attempts to expand. When compressed gas attempts to expand. I'll explain this section with a small experiment. Now look at the board very carefully. I'll explain with a small experiment. There you go. What is this? YouTube. This is a YouTube, Lamai. Shape tube. YouTube. You take a YouTube. Hurry. You fill some water inside it. You fill some water inside. Now this is water. That is the water inside the YouTube. Initially, levels of the water in both the arms will be equal. Levels of the water in arms will be equal. When you pour some water here, it goes to the other side. Levels will be equal. So initially, the levels are equal. Practical thing, when you fill some water, here the level will be equal. So initial, the levels are equal. Why the levels are equal? That is because pressure at A and pressure at B are equal. If the pressures are not equal, like I'm squeezing this, then the levels won't be equal. No? If I squeeze this more, then levels won't be equal. These two levels are equal because pressure at A and pressure at B are equal. That means both the sides are squeezing equal. If at least one side, if I squeeze more, from the other side, the liquid come up. So levels are equal because initially pressure at A and pressure at B are equal. Now what am I going to do? I take a balloon. Fill it with air. And I'm going to tie it using a thread. Using a thread, I am tying it. Don't put a full knot. Using a thread, you tie it and keep. So that when you need it, you can open the thread. Take that balloon, fix it to the one arm of the U-tube. Take the balloon, fit it to one arm of the U-tube. Now, practically think. When I open the thread, the compressed gas inside it will come out. The moment I open the thread, compressed gas inside the balloon will come out. Whatever the gas that is compressed there attempts to expand. It attempts to come out. The gas here attempts to expand. It tries to come out. When it tries to come out, y'all tell me, still, will the levels be same? When it attempts to come out, still, will the levels be same?
No, sir.
No, sir. No, sir.
Be same. What will happen? What will happen? From this arm, water will go down. From this arm, water will go down. From the other arm, water will come where?
Go up. Upwards.
It will go up.
Upwards.
From this arm, there you go. Water goes up. That is because on this arm, water is squeezed inside. Lama, if it is squeezed, what is applied there?
Force.
Pressure.
So squeezing is pressure. From this side, water is squeezed. Squeeze kiyanne, here a pressure is applied. From that arm, a pressure is applied. From this arm, it is going up. From this arm, a pressure is applied. That means the water is squeezed. Therefore, the water goes other side. Why did the water go down here? Why did the water get squeezed here? That is because here the compressed gas is trying to expand. So when the compressed gas tries to expand, what will be applied there? When the compressed gas tries to expand, what will be applied there? What will be applied?
Pressure.
Pressure.
Pressure will be.
Pressure.
Compressed
Pressure.
gas tries to expand, it will squeeze, again it is applying a pressure. So what is the pressure here? What is the pressure here? That is the pressure from the gas. Pressure from the gas. Pressure from the gas is only squeezing the water. What can you tell about the pressure here? What is the pressure there?
Pressure from the gas.
Now out of this, what is there? Atmosphere is there. Out of that atmosphere. What is the pressure here? That is
Atmospheric pressure.
atmospheric.
Atmospheric pressure.
I'll talk about it deeply. Today
Okay.
we'll have to discuss about atmospheric pressure. But just now, for now, keep in mind that is atmospheric pressure. So here it's the pressure from the gas, that side atmospheric pressure. That's why the liquid goes down. Okay. So from that we can understand gases can have a pressure when compressed gas attempts to expand, there can be a pressure. Pressure in gases when compressed gas attempts to expand. Take a YouTube, fill it with water. Initially levels of water in both the arms are equal. See, X, Y are equal. Fill a balloon with air, tie with a string and connect it to one arm of the U-tube. When the string is removed, compressed air tries to expand. Compressed air tries to expand. Therefore, level of X goes down. This is due to gas. Simple section. Okay. We'll do a question from that. Can you all try this question? Think and do it. Think and do. First think. First think and give it a try. Those who can work, do the question. First give it a try. Eh? Anybody found the answer? Hurry, we are getting answers. Hurry. See, will you? What is happening? A balloon is fitted there. Liquid level here is at X. then that side goes up. It has gone up to y. From where it has gone up? From this point. That is 2 centimeter. Simple thinking part is there. Here you have a balloon. Here the level is there. Level A. No. Level X, point A. Here point B. Level Y. The increment in the level is 2 centimeter. Here the pressure is P air. P air is pressure from the gas there. They have given the density of water 1000 kilogram per cubic meter. Gravitational acceleration 10. What is the question asking? Question is asking, calculate the pressure at A. Calculate the pressure at A. How to calculate the pressure at A? How to calculate the pressure at A? Right. Use yesterday's theory. Use yesterday's theory. Pressure at A. Lamai, this level and this level are same. No? Liquid is same. No? You all tell me yesterday's theory. Same liquid, same level. Pressures are same liquid, same level. Pressures are. You all tell me.
Equal.
Equal.
Equal, sir.
Same liquid is there.
Density is different.
Same liquid is there. Same level. Pressure at A and pressure at B are what?
Equal.
Equal. The
So if
density.
I find pressure at B, that should be the pressure at A also.
Yes, sir. Yes.
How to find pressure at B? More simple lamai. Forget about the full YouTube.
Exogy.
Forget about the full YouTube. B is here. This is the surface. Liquid is 2 centimeters. Density is given, gravitational acceleration is given. How to find the pressure at B? What's the equation?
H-Rho.
Exogy.
So apply H rho G there.
HEG.
Pressure at B, that is hydrostatic pressure, is H rho. H is 2 centimeter, convert it into meters, 2 divided by 100 meters,
100.
multiplied by.
Yusuf.
Multiplied by. Density of the liquid is 1000. 1000 kilogram per cubic meter. What is the gravitational acceleration? 10. Gravitational acceleration is 10 ms to the power minus 2. From there, hydrostatic pressure at B is 20 cancel off. 2 into 10 is 20. 20 into 10 is how much? 200 Pascal. That's the pressure at B. So pressure at B we know. Then we can write pressure at A. That's what they're asking. Hydrostatic pressure at A is equal to 200 Pascal. A and B will be equal. So first they are asking calculate the pressure at A, 200 Pascal. Roman 2, hence represent the pressure at B. Hence represent the pressure at B. A is 200 Pascal. Then B is also how much? Same level, same liquid. A 200 Pascal. Here 200 Pascal. I thought B also how much? 200 Pascal. So hydrostatic pressure at B, that we already calculated actually. 200 Pascal. Right? Roman 3. Hence represent the pressure of air. What is the pressure of the air now? That is this pressure. What is this pressure? Don't tell me Lamai. Here you have 200 Pascal. Here you have 200 Pascal pressure. Above this, what is there?
Gas.
Gas, the air is there. Air from the balloon is there. So above this air is there now. This 200 Pascal here came from what?
Yeah.
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 Who is actually squeezing there? Air. Because
Air.
just above this, you have the air there. So this 200 Pascal came from the air above it. Ehenang, what is the air pressure?
200
200 Pascal.
200 Pascal.
200.
200
The
Pascal.
pressure from the air is also 200 Pascal. The air is also 200 Pascal. Air is only pushing it. So air pressure is 200 Pascal. Correct? No? See, air is pushing it 200 Pascal. Air is pushing 200 Pascal. That pressure is acting here 200 Pascal. That is the equal pressure here 200 Pascal. So to balance it, this level goes up a little bit. First side you have additional pressure 200 Pascal. To balance it, this level goes up and it balances. Okay. There's a question why I divide by 100. You all tell me why did I divide by 100?
To convert it into meters.
Convert into meters.
Convert into meters. Right? You can't do the question using centimeters. You have to convert to meters. You have to divide by 100.
Sir,
Centimeters to meters, you divide by 100. Yes.
according to this YouTube experiment, gas pressure is used.
Yeah.
Yeah. Likewise, in the hydraulic press, what type of pressure is used?
In hydraulic press, Puta, we apply a pressure there. No? So external pressure is transfer. Externally, we go and apply it. Unless you apply a pressure, will the hydraulic press work?
No.
So we apply. Even in the brake system, the same. We apply pressure. Unless we press it, will it work? So external, whatever the pressure applied is only used there.
Okay, sir.
Okay. Those who didn't get it, write it.
Excuse me, sir.
Yeah.
For us to calculate the pressure at A, where is the height given for that?
To calculate the pressure at A, where is the height? That's the question.
Yes.
You can't calculate the pressure at A directly. You need to equalize it to B. B has a height. From there only you calculate. That's why we first calculate the pressure at B. Then we use the characteristic. Yesterday I taught the characteristics of pressure, hydrostatic pressure. Same liquid, same level, pressures are same. So first we calculate the pressure at B using the height there. Same liquid, same level, pressures are equal. So if B is 200 Pascal, A also should be 200 Pascal. That we take for the surface of the liquid. The surface should be 200 Pascal. Understood?
Yes, thank you.
Okay, welcome. හරි නේද? Those who didn't understand, again listen. What we do is, you all tell me, can we calculate the pressure at B?
Yes, sir.
How?
Yes.
What's the equation?
H rho G.
H rho G.
H rho G. So pressure at B, you can calculate it by H rho G. From there, how much we got?
200 Pascal.
Pascals.
Same liquid, same level. What can you tell about the pressure?
The pressure is also
Pressures are equal.
So if this is 200, then A is also how much?
200 Pascals.
At A, 200 Pascal is there. What is there?
Yeah, pressure is also 200 Pascals.
Yeah. So who is applying the 200 Pascal pressure?
Yeah.
Atmosphere, yeah.
That's it, question done. That's the theory. Yesterday's connection is that. That's why I told you. Yesterday, our characteristics pressure part is very important. Using that only we are solving this question. Otherwise, you can't solve this question. Same liquid, same level, pressures are same. That concept should be used. Huh. So that is the first part of gas pressure. When compressed gas attempts to expand. Now going to the second part. Pressure in gas due to weight of the gas column. Best example, atmospheric pressure. Pressure in gas due to weight of the gas column. That is atmospheric pressure. That's atmospheric pressure. Listen, there you go. Pressure in gas due to weight of the gas column. Best example, atmospheric pressure. Atmospheric pressure. Now listen very carefully. That is the surface. That is the surface of the earth. What is there above the earth's surface? Atmosphere. To about thousands of kilometers, about 700 kilometers, you have an atmosphere. To about 700 kilometers, you have an atmosphere. This is the atmosphere. Now listen very carefully. That's the atmosphere. Above the atmosphere, you have the space. This is Earth. This is Earth. So I believe that the Earth is flat. Earth is curved. That's what I'm going to talk now. Space things I'm not going to talk now. Hurry. Earth is curved. So Earth is there. Earth is a donut. You hurry. Earth is not donut, not flat, it's spherical. So Earth is there. Above the Earth's surface, you have the atmosphere. So 700 kilometers above Earth's surface, your atmosphere. Above that, you have the space. Above that, you have the space. In this atmosphere, Lamai, in this atmosphere, you have different gases. Nitrogen is there, oxygen is there, hydrogen is there, carbon dioxide is there, helium is there, argon is there. So many gases are there. Gas is a matter. Correct? No, one state of matter is gas. Matter has a mass. Gases also have a mass. Remember, gases have a mass. In grade 6, you learned it. Gases, they have a certain mass. You fill some gas in a balloon, keep the balloon in a sensitive weighing scale, you can measure the mass of the gas there. Gases have a mass. If gases have a mass, guaranteed they have a weight also. If gas have a mass, guaranteed they have a weight also. So remember, the gas in the atmosphere has a weight. Gas in the atmosphere has a weight. Now think, your friend is standing on the surface of the earth. Above him to about 700 kilometers. Gases are there. I already told you, gases have a weight. Gases have a weight. If so, above your friend's head, there is a big weight. Practically think. Above your friend's head, gases are there. Kiyanne, above your friend's head, there is a big weight. We all are holding that weight. Now it's like above our head, there is a set of books. You take some books and keep on top of the head of your friend. What do you feel? You feel a weight there. You get a bit squeezed, isn't it? Tell me, when you keep some books on top of the head, won't you feel squeezed?
Yes.
What's the leg between the leg? Ek leg නෙවෙයි ළමයි. Right. So when you keep some books on top of the head, won't you feel squeezed? On top of the head, if there are some books, won't you feel squeezed? Yes. So here we don't have books. What we have is gas. Gases also have a weight. ඒ කියන්නේ we are feeling a squeezing feeling there. That means on top of our head, there is a pressure applied. That pressure is coming from the atmosphere. What is that pressure called as?
Atmospheric pressure.
Atmospheric pressure.
Atmospheric pressure.
Atmospheric. Okay. Now don't think on top of our head you have books. Books maybe. Air is there. Just think what is on top of your head. Air is there. We all are holding that air. But we don't feel it actually. And do you feel? Is anybody feeling on my head the big weight? Do we feel it? Is there anybody who has that feeling? A big weight on the head. Our mother have a feeling. Eh? Mother always have that feeling. You are a big weight to me. You are a weight on my head. Mother has that feeling. But do we have feeling like a big weight is there on the head? And if we don't have that feeling, that is because from our birth, we are adapted to this. From our birth, we are here, we are holding this weight. Just imagine, from our birth, if we have a set of books on the head, after about 15 years, will we have that feeling? There are books on the head. Will we have that feeling? No.
No.
We won't have.
Yes.
The same way, from the birth, we have a air column above our head. So from our birth, we are holding some weight. We are getting squeezed. But we don't feel it actually. We don't feel. From that, the pressure applied is. So you can clearly see atmospheric pressure is due to what? Weight of the gas column. Weight of the gas column. Due to weight of the gas column, only you have the atmospheric pressure. Hurry. Now I'll ask you two questions. Let's say your friend is here. Your friend is here. This is point A. Suddenly he is here. Let's say you fix him in a Askur and send him up. Or like in Garfield will fix OD in Askur and send up. Okay, you send your friend up. Now your friend is here. B. You all tell me at what point your friend will feel the highest pressure? Is it at A? Is it at
A.
B.
A, sir.
Send the answer. Send the answer to the chat box. Otherwise, I don't know.
B,
I
B.
don't know who is telling what.
B, sir.
Send the answer to the chat box. Two people are also saying. Your friend is at A, your friend is at B, where he will feel the highest pressure. Two people are also saying. Don't go to ask from your friend. You all think and tell. Your friend doesn't train to think, no? You think and tell, will you?
B.
Put it to the chat box.
A, sir. A.
Highest pressure. My question is where highest pressure is there.
A.
Where highest pressure is there.
A.
A.
A, sir.
A, hiyo. 100% B.
B.
Alright, good. Almost all of you send the answer. Think like this, Elio. Atmospheric pressure is like some books above your head. Now consider the two locations. Where your friend is having lot of books. See, now A kyanne on top of his head. Oh man, this much of books. B kyanne on top of his head. Only this much. At which point he is holding a lot of books.
A.
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 Then where he is having the highest pressure?
A, sir.
A,
Now
sir.
tell me. Now tell me.
Yes, sir.
A.
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 Now tell me.
B.
A.
A.
Sir,
A.
it's B.
Because
It's
of
B,
B.
sir.
To the chat box. Send to the chat box.
When you climb a mountain,
Send to the
your
chat
ears
box.
go.
This is how you think. But A, he is holding a lot of books. Lot of books can squeezing is more. If squeezing is more, here the pressure is more. At B, only a little bit of books. Little bit of books can squeezing is less. Squeezing is less can my pressure is. What this tells us, when your altitude increases, pressure will
Decrease.
Decreases.
Decrease.
when your altitude increases, pressure decreases. Let's say you climb a mountain. When you climb a mountain, the pressure, the atmospheric pressure there will decrease. Right? More than the mean sea level. The
live பாக்குறேன்மா லைவ் பாக்குறேன் லைவ் இது எக்ஸ்பெல் லைவ் பாக்கல இது சயின்ஸ் கிளாஸ் இது புரியுது பாதி போயிட்டு தானே இது
So more than A, when you climb up a mountain, what will happen to the pressure? Pressure will decrease. Actually, if you travel to up country from a low country, right, when you are going to Canada, Badul, those sites, when you now those places you have to go by climbing mountain. No? Those routes are made through mountains. No? When you are climbing the mountain, there are some sharp Scandi Road. There are two sharp turns, sharp U-turns are there. That's direct vertical climb up. I can't remember the correct place. Direct vertical turns are there. U-turn, but vertically you climb up. When you climb up from up, you can see down. That is where usually police also stays. That is double line. Right? When we take the turn, on top police will be standing, will be looking at vehicle coming from down. Double line is there, you can cut the double line. So when you take those sharp turns, you are vertically climbing up. The moment you climb up, you can feel your ears get blocked and open. Sometimes it gets blocked. You have to swallow a little bit of split. Then it will open up. Don't you have that feeling when you all travel to up countries? Just can viewpoint we have that. When you climb up, right? You swallow a little bit, you have to swallow a little bit of split, then you will feel that ears block can open up. Why? Now our ear, inside the ear, you have the eardrum. Eardrum, it is pressed by the atmospheric pressure. The moment you have a sudden change in the atmospheric pressure, eardrum will come out or it will go inside. So when it come out or goes inside, then you feel that you get blocked. All right, next time when you travel up country, just see whether you have that feeling. Sometimes you can't hear your friend talking. Just after you take a turn, you can't hear your friend talking for some time. It will be fully blocked. And quickly swallow some split. Right? Then you can again feel that. Okay. You don't need to actually swallow a split. You just are block open karna can you have to just like swallow something. That way you can feel. So going to atmospheric pressure. Earth's atmosphere extends to hundreds of kilometers above the surface of the Earth. Similar to the pressure produced at any point inside a container filled with water. Now this is like a container filled with water. It's like container filled with water. So under the water, the deeper you go, the more pressure you feel. Same. Above you have air. So due to the air, there will be a pressure. Similar to the pressure produced at any point inside a container filled with water by the water above that point. A pressure exists at any point in the atmosphere due to the weight of the air above that point. Again, I repeat, above that point, not something below that. This pressure is known as atmospheric pressure. Atmospheric pressure decreases when you go to the higher altitude because the weight of the air above that point decreases. Please underline or highlight that. Atmospheric pressure decreases when you go to higher altitude because the weight of the air above that point decreases. So when you go to higher altitude, atmospheric pressure will decrease. Generally, atmospheric pressure is defined respective to mean sea level. Usually, we define atmospheric pressure to what level? To the mean sea level. What is mean sea level means? What is mean sea level means? Average sea level. Okay. Harinir. We'll solve this barometer section, right? This barometer section. Then I will send you all. Right, we'll quickly solve the barometer section and send you all. 11, no, 11.5. Hurry. Now, Lamai, how to measure atmospheric pressure? How to measure atmospheric pressure? Atmospheric pressure is measured using barometer. Think what measure atmospheric pressure? Barometer. There are two types of barometers. What are the two types of barometers? Number one, Mercury barometer, and number two, aneroid barometer. The two types of barometers we have: Mercury barometer, aneroid barometer. I'll first discuss about Mercury barometer. First discuss about Mercury barometer. Mercury barometer. Actually speaking, you can make a Mercury barometer at your house. You can make it to measure atmospheric pressure. How to make Mercury barometer? See, now look very carefully. How to make a Mercury barometer? You take a big container. Usually you take a trough. Trough is a little bit of a bigger container. A big container. And fill it with mercury. What is there inside this? Mercury. You take a bigger container, fill it with mercury. Right? Next, you take a boiling tube. Not actually a boiling tube. It should be a tube bigger than the boiling tube. A glass tube, a long glass tube. Let's take this is the tube. Right. It with mercury, close it, take it, put it upside down on top of this. Fill it with mercury, close it, take, keep it upside down on the mercury. Take, fill, close, upside down. You put it upside down. The moment you put it upside down, what will happen? Little bit of mercury will go down. The moment you put it upside down, little bit of mercury goes down. There you go. මෙහෙම little bit of mercury, not all the mercury. Little bit of mercury will go down. If you measure the height of the mercury here, when the barometer is in sea level, when the barometer is in sea level, if you measure the height of the mercury here, height of the mercury will be exactly 76 centimeter. What will be the height of the mercury? 76 centimeter. Exactly, it will be 76 centimeter at the mean sea level. Now, y'all tell me, what is there here?
Vacuum.
Atmospheric
Vacuum.
pressure.
A vacuum.
A space is there. A vacuum is there. Don't think air is there. Actually, nothing there. Because first we fully fill with mercury. We close it, take it, keep it upside down. The moment you keep it upside down and open it, mercury will go down. Nothing goes inside. That means here what is there is vacuum. A space is there. You call it Torricelli's vacuum. A space is. What is there above this Mercury? Above this, what is there? These places, what is
Atmospheric
there?
pressure.
Atmosphere.
Atmospheric pressure.
You have the atmosphere.
Right.
Atmosphere is there above this. Alright. Now see, now listen very, very carefully. Now listen very, very carefully. I take this as point A. Same level, this as point B. Above point A, what is their atmosphere? So above point A, the pressure that is acting there is what pressure? Atmospheric pressure.
Atmospheric pressure.
Agree with that?
Yes.
Yes.
Above point A, atmosphere is there. So the squeezing there is weight of the air column above. That is atmosphere. Above point B, what is there?
Pressure of mercury.
Mercury is there. So above point B, the pressure there is pressure of the mercury. Above point B, the pressure there is, I will mark it as PB. PB is pressure of the mercury only. Why? Above it only vacuum is there. Agree with that?
Yes, sir.
Yes, sir.
Yes, sir.
Above point A, pressure is atmospheric pressure. Above point B, pressure is mercury pressure. Above it, nothing is there. Directly vacuum is there. Now, A and B are at the same level. A and B are same liquid. Ehina, what can you tell about pressure at A and pressure at B?
They are equal.
Both
are
are
equal.
equal in pressure.
Both are equal, sir.
Last week work.
Equal.
Same level, same liquid, pressures are.
Equal.
I take density of mercury as 13,600 kilogram per cubic meter. Gravitational acceleration 10 ms to the power minus 2. Don't need to memorize the density, they will give it. Right? Now I'm going to write equations. See how I'm going to write the equation. Listen, now the most important part. A is there, B is there. What can you tell about pressure at A and pressure at B? Both are
Equal.
equal. Why equal?
Equal.
Same liquid, same level, pressures are equal.
Equal.
Pressure at A is due to atmosphere. That is atmospheric pressure. Pressure at B is due to what?
Mercury pressure.
Mercury pressure. Mercury pressure kiyane I can apply the equation H rho G. Agree?
Yes. Yes, sir.
Do I have the H value? Yes, 76 centimeters. Do I have the density rho? Yes, 13,600. Do I have gravitational acceleration? Yes, 10. Now we'll apply the equation. PATM, atmospheric pressure, is equal to H is 76 centimeter, convert it into meters.
400.
Over 100.
Divide by 100.
Multiply it by density of mercury is 13,600 kilogram per meter cube. Gravitational acceleration 10 ms to the power minus. If I go one more step ahead, atmospheric pressure is equal to 0000 cancel out. 136 into 76. 136 into 76. 1, 2.
10,336.
10,336.
That is 6, 3, 3, 1, 10. 1, 0 is remaining. 103,360.
Pascal.
103,360. If I write this in scientific notation, your atmospheric pressure is 1.0336 into 10 to the power 1, 2, 3, 4, 5. 10 to the power 5 Pascal. I can round it off and tell atmospheric pressure is almost equal to, this symbol means what? Almost equal. When I round it, 1.0336 can 1.0 1.0 into 10 to the power 5. This is at what level? At mean sea level. At mean sea level only you get 76 centimeter. At mean sea level, atmospheric pressure is this value. When you go up, what happens to the atmospheric pressure? Increase or decrease?
Decrease.
It decreases. So remember, at mean sea level, atmospheric pressure is 1 into 10 to the power 5 Pascal, a round off value. Okay. How did I get it? How did I get it? Using mercury barometer. That is how you measure atmospheric pressure using a mercury barometer. So what is mean sea level? Normal level or different? Mean sea level කියන්නේ පුතා. You go to a beach, stand. You can see a level that is considered as mean sea level. Average sea level. Okay. Go to the tube. Mercury barometer. The device used to measure atmospheric pressure is mercury barometer. Mercury level at mean sea level will be how much? 76 centimeter. From this, atmospheric pressure can be calculated. Density of mercury is given 30,600. Gravitational acceleration is given 10. Here it is given as x and y. Need. So we'll apply the equation for x and y. In that box, write the calculation. I will write it as x and y. Pressure at x equal pressure at y. Work.
Finish, sir.
Okay.
Done.
Sir, done.
Done, sir.
Okay.
Done, sir.
Okay.
Done, sir.
Answer.
Okay.
Done, sir. Done, sir. Done, sir.
හරි නේද? Few special points are there. We'll discuss the special points and finish it off. Now, who actually made this mercury barometer? Who made mercury barometer? There's a person called Torricelli. What Celli? Torricelli. So Torricelli is the first person to make it, and he only measured atmospheric pressure for the first time. Atmospheric pressure was measured for the first time by an Italian scientist called Torricelli. Special points. At mean sea level, always, what is the vertical height of the mercury column here?
76 centimeter.
76 centimeters. Always it is 76 centimeters. Tell me that in millimeters, Laman.
0.7.
760 millimeters. That means sea level, always the mercury column height there is 76 centimeters. Point number 1. Special point, always the vertical height of the mercury column in mercury barometer is 76 centimeters. Right. Special point number 2. How does this height changes? If you take the barometer to a high altitude, or if you take the barometer to a low altitude, then pressure will change. Then that mercury column height will also what? Otherwise, at mean, always what is the height of the mercury column? 76.
76.
At a high altitude and at a low altitude, this can only at high altitude and low altitude will change. At mean level, sea level, 76 centimeters. So point number 2. This height will only change when the barometer is lifted to a higher position or a lower position from the mean sea. Next, if you slant this glass, if you slant the glass there, what will happen? Even if you slant the glass, the vertical height won't change. Vertical height can is straight height. Vertical height still will be 76 centimeters. Maybe the slanted height might change. Maybe never. Surely it will change. You have to apply Pythagoras to find it. Here you can see a triangle. Slanted height will surely change, but guaranteed the vertical height will never change. So even if you slant it, will the vertical height change?
No.
No.
If you press it, let's take you press it inside. If you press it inside, what is going to change? See, let's take this is the original barometer, normal level. Let's take you go and press it. If you press it inside, only what has changed? The vacuum.
Vacuum.
Only the vacuum will change if you press it. Still, will the vertical height change?
No.
No.
Remember, for the vertical height to change, pressure should change. Atmospheric pressure at mean sea level does not change. Even if you press it from top, only the vacuum will. Now, some fellows will ask me, so if I proceed too much inside, the moment you proceed, let's take until this level. Until this level, let's say you proceed. On top of this, do we have a vacuum?
No.
Our pressure is only there. Our thing is only there. So are we measuring atmospheric pressure there?
No.
So the moment you pass that level, then after that, our pressure will, the full story will turn upside down. As long as a vacuum is there only, we measure the atmospheric pressure. As long as the vacuum is there, we measure atmospheric pressure. The atmospheric pressure is always 76 centimeter, cannot be changed. Okay. Those points are given. This height will, if the glass tube is slanted, still the vertical height of the mercury column remains the same. See, vertical height is the same. If the glass tube is pushed in, only the vacuum space will reduce. And the vertical height of the mercury column still remains the. Okay. Finally, what are the units? What are the units of measuring atmospheric pressure? Atmospheric pressure, we already know, is measured in pascals. Is that all? No.
No.
You can measure the atmospheric pressure in centimeter mercury, Hg is mercury, as well as you can measure atmospheric pressure in millimeter mercury. All these are units used to measure atmospheric pressure. You all tell me, what's the atmospheric pressure at mean sea level? We calculate.
1.0 into 10 to the power 5.
1.0 into 10 to the power 5.
5.
That is equal to how much of centimeter in mercury? Now see, at mean sea level, how much of centimeters of mercury is there?
76. 76.
So that is equal to 76 centimeters of mercury. Now tell me that in millimeter mercury.
760 millimeter of
760 millimeter. So 1.0 into 10 to the power 5 Pascal is equal to 76 centimeter mercury or 760 millimeter. Atmospheric pressure can be represented in centimeter mercury and millimeter mercury as well. In that box, write this.
So I've got a question. Can I ask?
Yeah, ask.
According to the second point, right? The height will change according to the place where the barometer is. So how will it change? If will it increase or will it decrease?
That part I will explain next class. When you go up, when you go down, what happens? You think when the pressure decreases, what is going to happen? And when pressure increases, what is going to happen? You think.
Sir, can you please cite?
Hurry, okay. So should we memorize it? Yes, better to memorize it. Nothing. 1 into 10 to the power 5 Pascal. This is at mean sea level. Finally, there are some questions. Questions I wanted you all to do it as homework. Question 1, question 2, question 3. With that, important point is there. With that, barometer section will be over. Now, what is remaining for us is aneroid barometer and then cross section. Only small section. Hurry. So do the questions as homework. Any doubts?
So will there be free session
No.
for the rest?
Sorry. There's someone asked.
Will there be a free session for the rest of the?
I didn't get you.
Will there be a free session for the rest of the lesson?
Sorry, but this thing is not clear. I hear a bass voice. Can you type it?
Okay.
It was clear. So I learned this lesson with many teachers, but I didn't understand. Now I'm crystal clear. Thank you. Rest of the session, when shall we put? We'll take a day, put and finish it off. Next week. Monday, Tuesday, Wednesday. On about today is what day? Today Friday, no? Next Friday, we shall we take a night session or Thursday night session? Night session, 9 o'clock. 9 to 10, 11.
What about Thursday night?
Coming Friday is holiday, sir. Really? Yes, no, you all are getting your school holiday on 22nd. I thought during a holiday season shall we catch up one day?
Okay, sir.
For us, no leave. Some set the list, some set as anything on 20 next. We'll take a late night session because we have class until what time?
12 o'clock.
Yeah, I have. So at about 9:30, 9:30, 10:30, 11:30. Okay. Night session.
Okay, sir.
Okay.
Okay. Okay, sir.
Next
Okay.
Friday.
Okay, sir.
Session.
Okay.
Okay. With that, we'll finish off the session. You all do the questions and come, man.
Okay.
Hari, just send a comment to the YouTube video whether you all understood the session, how you all feel about the session as well. Okay. Okay, then enough for today. Then. Thank you and God bless you. Keep working.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir.
Bye, sir.
God bless you, sir.
Bye.
Thank you, sir.